So friends, in this video I will be talking about velocity and acceleration of particle in simple harmonic motion wave. The typical formula for the SHM wave is y is equal to a into sine omega t minus kx, where a is amplitude, omega is angular velocity, t is the specific time at which we want to calculate this displacement, k is the wave number, which is 2 pi by lambda, the x is the position of the particle along the x direction. Now, if you know like any equation, then you can easily find the velocity and acceleration of a given particle. So to calculate the velocity, there are a couple of ways. First one is we can differentiate that equation dy by dt. So this equation y is equal to 2 sine pi by 2. This full equation is a displacement equation, okay? And if you differentiate with the time, you will get the velocity. So the velocity will be 2 pi cos pi by t into 2t minus 5x. So that is the differentiation for the above equation. Once we differentiate that, basically this is the velocity. Okay, so you can put the values of the time and then x, and you will get the velocity, value of the velocity. And let us say you want to find the max velocity. So max velocity will be when this particular component will be maximum. Okay, because that is the only component that is changing. So cos function's range is from 0 to 1. Okay, it ranges from 0 to 1. So you can see that this function will be maximum value of this cos function is 1. Okay, and that's why velocity max will be 2 pi, because 2 pi and it is saying cos say xyz. So this whole thing is actually 1. Okay, and then the velocity will be maximum. Also you need to remember this formula as well. The maximum velocity is given by plus minus a omega, where a is the amplitude, this value, omega is the angular velocity. So in this case, amplitude is 2, okay, and omega is pi, okay, omega is pi, because 2 will cancel out. So with this formula also you will get the correct answer, and using the differentiation also you will get the right answer. And also you can use that equation to calculate velocity at any given position like x and t. So if you know the x and t of the particle, then you can find its velocity using this equation. Now next thing is acceleration of the particle. Once we know the velocity equation, so you can see that we have calculated the velocity equation. Then if you differentiate that equation with t with respect to time, once again, that is we are doing the double differentiation of this function y with respect to time. What we get is minus omega square y. That is the acceleration of the particle when it is displaced by y. And maximum acceleration is this one, plus minus omega square a, because y's max value will be a. Other way to find the particle velocity is by using this equation minus v wave, that is wave velocity, into dy by dx. But dy by dx is actually the slope, right? If you plot this x and y, then dy by dx is basically the slope. So this is also another equation that you can use to find the particle velocity. And this equation has been derived by differentiating wave equation with respect to time and x. Remember that the wave equation depends upon time and x. So basically we have to differentiate once with the time and once with the x, and then equate those equations. Then we will get this particle velocity will be minus v wave into dy by dx. And using the simple harmonic motion, we know this formula as well. Particle velocity is equal to omega into under root of a square minus y square. So you can see that there are three methods, 1, 2, 3, to calculate the velocity of the particle. So this is the third one that we have seen, omega under root of a square minus y square. The second method was minus v wave, that is wave velocity into dy by dx. Okay, and initially we saw that whenever we have got this equation y is equal to a sine omega t minus kx, so we have to basically differentiate the dy with respect to time, and whatever we will get, it will be basically the equation of velocity. So you can see that there are three ways in which you can calculate the velocity of the particle. Thanks for watching.